Welcome, I'm Bill Wake. We're here working on a calculator for Kilts, and we've come a long ways on the Pleat Designer. We've got some refactoring to do, and when we finish that, we're going to look at the EGTest package and see if we can extend it with some things we picked up along the way doing this project. Last time I was sure we'd get to both those, and this time I'm not promising. Okay, let's kick off tests. But we're in here. This formatter it's basically the one that's supposed to do fractions for us. Okay, so the key pieces, let's go to the bottom. The value formatter itself takes inches or numbers, and then it formats them as fractions. So there's a fractional format, FractionFormatter. That's the thing that puts in the dot and the slash and all that stuff. And then there's a thing we call split double that started off as a way to get the fraction, the whole number and the fraction out of a number. And we've extended it, but I don't think we've extended it quite enough. All right. Check the original value against the, yeah. So, well, I guess that's probably the big thing. Yeah, so we kind of did that, I think, right? That was this skosh cutoff. Okay. Oh, did we get things done right at the beginning? I know I was still a little unhappy with the balance between these classes. Like some of this stuff. This code is kind of, I don't know, it felt a little awkward. Tests started failing, but they were supposed to fail because they weren't designed for the change. Yeah, we did have to fix some tests to take into account the new difference in how close they were, but looks like we're all done with those. Well, okay. Yeah, so I don't know. It's like, how much abstracting do I need to do? But one thing that occurred to me was this thing could know all that arithmetic stuff about what's the, what are we rounding to and all that. We got this rounding denominator coming in. Let's see, I don't know who calls this. Oh, file private, so it could be used down there. Yeah, okay. Right. Because then it does all this adjusting. And then we go back up here to get the adjustment. See, like, yeah, I don't know. I'm a little bugged. I guess it's okay. This thing, well, okay. Yeah, I'm bugged because this is all looking at the arithmetic and deciding what to display. And then, gosh, I don't know, so in this case, like if you get something that's 99/100ths, it's going to be closer than a 16th of an inch, say, or 64th or whatever our number is. This adjustment, like, I don't know, do we need the split number? I mean, it's all being used for this. We take a number, we split it, we get the sign, the whole number, the fraction parts, then we adjust them, and then we convert the sign into a minus or nothing, and then we format according to that, but then we calculate the adjustment Like I'm fine for the formatter to be playing with strings, but I don't want it doing arithmetic. And maybe this split number, maybe it really wants to be the representation of the fraction and the sign. Okay, so I'm going to take this as a chance to do a little bit of abstraction and some plain old reorganization. Okay, so here I'm going to introduce yet another enum. This is a skosh. You got a none, plus, and minus. Okay. Now I think, oops. Sorry. Get this. All right. I think, given those, somebody should answer what your skosh is. And I think it should be that thing. Okay. And so this calculation, oh, and I want to do kind of that compromise thing. None is empty, plus is circle plus, and this is circle minus. Okay, so I think that makes this effectively the constant. Okay, so now all right, I guess I'm gonna split the computation and then return the result. Okay, so if okay. No, I want to do this safely. How can I do that safely? I'm going to say skosh equals none. Okay, and then at the end, well, this is really kind of a don't happen now, but I think we're going to make it a happen. Skosh dot raw value. Okay, now none. Okay. Now, I think if I take this off, well, I think I can make these else's. Okay. Oops. Well, I think we have tests for each case. I mean, are you worried about the cutoff? We can, yeah, let's come back to it, I think. I mean, I'm doing stuff that should be pure refactoring at this point. I'm doing a variable, and my claim is if this is less than cutoff, there's skosh. Well, there's nothing else that can happen for it because we returned it. So now I can say else if, And same thing here. Okay, let's make sure these are. Okay. Well, I don't mind renaming that, I guess. Empty. 0. Unneeded. No, nothing. Okay, and now I should be able to drop any of these because it should pick up from the value of the string. Unless you crash Xcode. Where's my window? Okay. Something like that. Let's try that again. Okay, and then by analogy on these, they'll both work. Okay, now this method. Rounded and original, where are they coming from? All right. Okay, so find adjustment. We pass in the number and the split double. Okay, so I want to say this number could be on the split double. Okay, so let's... Let's move the method over, and then we'll use it. Okay, so yeah, that thing's almost like a pure function, really. Okay. So now here, I should be able to, what's the right name for this thing? I'm going to say it's adjusted. Adjusted number equals that. Okay. And now the adjustment is adjusted number dot find adjustment of this. As double. Okay. And now adjusted number, the original one, find adjustment, should be used, not at all. Okay, so this totally moved. Okay, now let's play with this one. Okay, so this one rounded. Well, let's let equals self.as double. Okay, that should work. Okay, now we don't need the new argument, the second argument rather. Okay. Okay, and then I want to return a skosh and call raw value on the result. Okay, I'm going to rename this. I'm going to rename original. I'm going to rename this to versus and fix that down here. So I can see if that reads right. Okay, so adjustment is the adjusted number skosh versus a number. I think original value is really a better name. Original, maybe that's good enough. Format original. Okay, and then adjustment, I'm going to rename to skosh. Okay. Oh, did I not rename that? Sloppy. Actually, I don't need to. Say versus original. Okay. So the caller, it says skosh versus some number. We call it original. Okay. Yeah, I'm okay with that. All right, let's commit that. Move skosh calculations up to split double. Okay. Now, all this stuff comes from the original split double. So, okay, what's off here? Okay, just that one line. All right, now this is where so what I'm thinking is I got to find a better name for this. I think maybe it's like a rounded fraction or something. Let's try that on for size. Okay, now, because I really want to just ask, I really just want to ask this thing, I want it to do all this stuff. Because all the information it needs is coming from original number. And it has access to as much of this as it needs. We'll still have original. We may not even need to pass. I mean, we could just hold it. All right, let's see what we got. Okay. I don't know what happens to fraction. I think fraction equals halves. This is all rounded fraction. Yeah. That's all being used here. Then we return numerator denominator. Okay. I think I want it to know these things. Okay. I'm gonna let's make a var for the original. Okay. And let's hold it. Okay. And now we well, I'm kind of trying to get rid of this one. No, this should be double of whole number. Yeah, that's what I'd like to do is get everything inside there, and then a rounded fraction can answer what's my numerator, what's my denominator, all that stuff. Okay, so I think we should harmlessly have the original now. There's no reason to pass that to get the versus. So let's take this parameter out. Okay, and notice we're using the same name, so there's no problem there. This should still pass. Oh, famous last words. Okay. All right, let's undo. Okay, now. Oh, this rounded fraction is not getting the original. I want to get rid of this one, so I don't know. I guess we'll pass it in this case. And so that second initializer takes original of double, and I can assign it first. In signum. Original double, signum of int. Oh, I do have in signum here. Okay. Okay, and now I should be able to remove that from skosh. Okay. All right, so far so good. Numerator, denominator, come in as its. Okay. All right, now. So if you get a rounded fraction, signum is split number dot signum, and that carries through. Actually, adjusted number has it too. So sign marker, well, okay, that's a string calculation. That seems okay. This is the formatter, so it's kind of its job to know that. I guess the sign of the input is going to be the sign of the fraction number too. Yeah, we do need the signum outside because the formatter wants to know whether to put a minus or a nothing. Okay, so, but maybe the sign is the sign. Okay, so this is also adjusted number. Okay, which I do kind of want. Okay, so let's make sure that's okay. How is that aligned? Like, oh, okay, the other one. Okay, so move toward rounded fraction calculating numerator and denominator. Yeah, it can be, but I think what I want to do is given the original number, break up this double into the pieces. So a sign that's positive or negative, a whole number, a numerator, a denominator, and then I want you to just ask pass those in here. And format whole number is local here. Yeah, I mean, it's got its stuff to do, so I think that's okay. But I think we're going to ask it from this, the rounded number we create up here is going to know that. Split number, signum, nothing changes that. I'm going to inline that. Do I care? I don't think I care right now. Okay. Whole number, split number. Okay, whole number is also passed through and nothing changes. Oh, it does. Okay, I'm going to get things in there first. All right. The whole number. Now, the numerator denominator, that's fraction parts. Okay. I'd like to know those. Let's see if I can frame this how I want it. Okay, the original's kind of one thing. This whole number, I don't really care about the fraction, but what I really want is numerator of int, and I'll just say 0 for now, and denominator of int. Okay, and the skosh, and those are all the things you need. Okay. To format it. Okay, so it takes the original number, does whatever fractionalizing stuff it needs to do, and then it should return these two. Okay, so did I make them var? Yeah, they are var right now, but I don't know if they have to be. Okay. Yeah. All right. So this split, I mean, these things are what I want to happen in the setup of it. Like once you've set all those, you kind of know. And where's rounding fraction? Rounding denominator. Let's pull that up. Into rounded fraction. Okay, that kind of makes sense. It would know that. Now, this stuff, okay. I would like okay, so you give me a number, we calculate the fraction, and then I want to do this. I don't know if I can call that thing quite yet because I'm in a constructor. Cannot find split number. Okay, that's now this is the tricky step, I think. Well, it will change whole number. This thing does. Okay. And then I think it's going to be the tricky step in the whole thing. All right, so we're applying this stuff. And then we want to format whole fraction. Well, I think that's the thing. That should be coming off of adjusted number. Okay, so if, sorry, off of split number. So, okay, I'm saying take this off of here, let it apply it from that thing. Now, the rounded fraction is what it knows. And this should be split number.signum. And okay, I got to account for this thing. Okay, so, whoops. I think this is the critical step. Rounded is self.double. I don't think this is right. I think rounded is going to be so rounded is going to be double of signum. I think this is where I'm putting this formula I had earlier of whole number double of absolute of whole number plus this, which may be a bit much. Okay. I'm taking a big leap here, I guess. Probably too big. This should go. And then this is well, it's going to be split number. All right, let's see. Okay, promising. All right, so what's this, line length? All right, fine. Okay, let me clean up. Okay, there's more to do, but all right. I don't think anybody's using. I'm gonna well. Okay, I don't think anybody's using that other constructor now. Good. Okay, was a goal to get rid of that. Now here's as double. Look what it is. It's double of sign plus whole number plus fraction. And I think it's fraction is, well, it's what we split off. Abs of fraction part. And I think this should be the same as this. Now numerator and denominator, they're coming from fraction. Fraction, I'm kind of talking myself in, but fraction is always positive. So denominator is always positive because it starts at a whole number. This is positive. Okay, so my stuff can't be negative. Abs of whole number. I think we made whole number absolute too. Okay, so let's make this our as double, and then we'll simplify that. Okay, make sure that works. Okay, so the way we construct numerator, it's always positive. And the way we construct the whole number, it's always positive. Okay, so double plus whole number plus double of numerator divided by double of denominator. Okay, that should still be happy. This is now self.as double. Okay. So we make rounded fraction compute the numerator and denominator. Okay. Yeah, as double should put it all back together. Okay, and I want to simplify pieces as I go, but I make sure I'm on track for what I'm really thinking here. Okay, so I don't think anybody's looking at fraction at this point. Abs of fraction, oh, numerator, this one is. Okay. Okay, I'm going to simplify skosh. Okay, if all we do is return the thing we had, I think we can say return nothing and then return plus. And then this is really just a plain old else. If rounded is equal, then rounded minus original is certainly less than the cutoff, so it's a nothing. Otherwise, if it's less than the original, otherwise it's got to be greater because that's our only choices. Okay, so this should be fine. Okay, we don't need the variable now. Okay, and then I think I can accept this. We're using it twice. Okay, we get ourselves, if it's below the cutoff, if it's less than the original. I kind of want to swap these. Rounded greater than original is the same as original less than rounded. Okay, let's do it properly. Okay, this is return minus. This is there because it's kind of the can't happen case that we're using. All right, so if rounded is greater than original, then original is less than rounded. Okay, I think I like that better. Whoops. If original is greater than rounded, well, actually, I think it's better the other way. Okay. I keep trying to screw myself up, but I refuse to do it. If rounded is greater than original, return minus. That's the really original is less than rounded. Gosh, make sure I'm not messed up. Yeah, fraction is the original fraction. Yeah. Okay, so, well, I just want to swap these two cases first. That's definitely legal. If they don't depend on each other, they're mutually exclusive. So, if rounded is greater than original, return minus. If rounded is less than original, return plus. And we said this really can be an else. Okay. And now, if rounded is greater than original, if rounded is greater than original, then original is less than rounded. Which I think makes sense that the fraction was actually a little bit lower, so it should be minus. Okay. That seems right. Okay, so simplify skosh. And actually, I have a further simplification. Yeah, let's, you're making that point. Let's call this original fraction. Okay, I kind of feel like we can get rid of it at some point, but let's get there first. Okay, now this I would like to be one of these calculated variables. Okay, so after the init. Okay, and then let's make this, well, I think he's okay as public var skosh of type skosh. Okay, and then the caller should be breaking. Yeah, there we go. Doesn't need parens. Okay, so to me, it makes the appearance that the number has these pieces and we can just use them. Okay, now, all right, let's make skosh I forget the term for that. Make skosh a computed variable. Yeah. Okay. And so original fraction, I don't think anybody outside this class needs, right? We set it in the constructor. We look at it in the fraction parts method. Okay, so this is private. Okay. So the skosh is double. Now fraction parts, where's that being used? In here. I mean, he's got some work to do. Rounding denominator, I don't think we need that. I mean, it's already there. Where's the color? Okay. Fraction parts. Okay. Well, I think his public interface is better now. You give it, it knows the original, and then it can tell you the signed whole number, numerator, denominator of the rounded fraction and skosh. And those are the things you care about. As double, I don't know if anybody's using that. No. I think I can make that private. Okay. So clean up in rounded fraction. Okay. Now we'll deal with the caller. Down here. Okay. So I think let's call this rounded fraction. Okay. We get the signum. I don't think we reference it anymore, right? Rounded fraction dot signum. Signum. I don't think it's being used. Am I misreading this? Yeah, I don't know why it didn't highlight that as unused. Okay, rounded fraction. The whole number, well, we're not doing anything with this one either as far as I can tell. Okay. All right. Formatted number, we're going to take the rounded fraction sign. I guess I can do that in order. Okay, so we're converting each thing. Now this thing, I think he should just take the rounded fraction since all he's doing is pulling numbers, values from it. We'll just duplicate it and work on the duplicate. Okay, so this is going to take a rounded fraction of rounded fraction. I'll just call him value. Okay, so that was one of the little kind of safe move ways. So I didn't have to risk all those places being wrong. Okay. Let's see. So I take the rounded fraction. If it has a fraction, if the numerator is not 0, Well, I think we've superseded this part of it. If value number is equal, it can't be equal to value denominator because of the way we constructed it. Okay, so we make sure if the numerator and denominator are equal, we change them. So that's not going to happen. All right, so let's take that case off. All right, and then this question has fraction. That seems like something we should be asking value. Okay, so let's make a helper for that. Okay, it has a fraction if the numerator is not 0, and that's really, well, it's just numerator. Okay. And then has fraction not value dot. Well, I guess the same argument here. Value dot whole number not 0 is kind of like has whole number. How do we get a 0 out of this if things are 0? Okay, if the value whole number is not 0, it makes more sense to get okay, is the value already signed? I'm not quite sure where you were asking about. I've been bouncing around. I'm gonna what's the word for this? It's, well, how do I get a 0 if the whole thing is 0? Am I missing something there? If the value whole number is not 0, then I do the first thing. If a value has a fraction, oh, I always add it in regardless if it has a fraction. But what if it's 0? Okay, let's just add the test. Well, I still want to get this phrase. If the value whole number it's like has non-zero whole number. I don't know if that's a really good question. I think we have a problem here. Let's see, test rounding. I don't know if, I guess we're looking at and it's kind of the same work. I just think the name is different. Okay, so what if 0 equals, we expect 0. And then 1, expect 1. So a non-zero whole number, zero whole number, and then let's do a exact fraction. And then four and 1/16 we expect, well, maybe 4/16. Let's give it some 5 and 4/16. We expect 5. And then this mess. Whole number is only 0. Yeah, you only get the fraction. Yeah. Whoops. I think I've got an extra case there. Well, we got some negative numbers to do too, but 5 and 4/16. We expect 5 and 2/8. Exact fraction. Okay. Now, the negations. Oh, yeah, it's a twiddle. Okay. -1. Okay. And I think these should pass, but I guess I don't quite see how 0 passes. Need to read the code again, I think. Uh-oh. 5/16 plus. Did I... His colon is... slash. Oh, maybe slash is... colon is divide? I mean, where is it? That. Divide up. Oh, colon is divide. Slash is slash. Okay. Well, yeah, you're right. 369 missed the minus sign. Oh, you're right. Oh, I hit an equals. Okay. Golly. Okay, so it's my ignorance of the code flow here. Result is empty. If the value is not a whole number, or it has no fraction. Okay, if it has no fraction, then we just do the whole number. That's the 0. Okay. But that's okay. And then I think your comment from way early that we probably should check these, just the, well, we've checked the rounding, but we want to check right on the border. Okay, so let's make a test for those things too. So these are the boundary cases. Okay, so if we get 1/64th, I think, what do we expect? I think we expect 0. I don't know if it's a less than or equal or not. I don't remember our calculations. Where's skosh? Oh, I'm on the wrong class. Okay. Rounded minus original is less than cutoff. Okay, so rounded is original's 1/64th. Rounded is 0. I think this one is not going to work. I want to see it break though, because I'll make it 1/65th after that. Okay, so let's make sure this does break. Okay, yeah, it gets 0 plus. Okay, so let's 1/64th equals 0. Still you. Plus 1/65th equals 0 minus. Okay, I'm sorry, just 0. And then we want a case with a minus. Get a skosh here. We want the case that's just a minus. 1 minus. Okay, if we did if we did 63/64ths, is that going to be enough? Okay, so 63/64ths, the value is 1. The original 63/64, so I think that's actually equal to the cutoff, right? So that should fail. Oh no, he should get a rounded, right? Okay, good. All right, and then I guess I want to make sure. Let's do 1/28ths. If I do 127 1/28ths, that should just be 1 because it's too close. Okay, with plus skosh rounded 1 with minus skosh. Okay. Test boundary conditions on skosh calculation. And I'm not sure what I probably should have just put it in when you said there's no advantage to having waited, because we theoretically have been refactoring this whole time, so nothing was going to change. All right. Well, I'm much happier with this. I think it could still be better, but I don't know if these won't be too crowded. But I'm definitely much happier with this. I think this thing, it moves beyond its original purpose, and now it gives us something that just says, I know how to break up a number for you. I'll keep track of the original for you, but really between sign, whole number, numerator, denominator, and skosh, we can tell you what you care about in terms of formatting. Okay. And it's kind of custom designed for the formatter, so we get to use it here. Okay. Yeah. All right. I'm definitely happy. I think we're caught up. No. Just spacing. Oh, and I still have a too long. Or did we clean that up? Okay, I guess we did. All right. Yeah, I think it's better. I don't know. I look at all our value imperial formatting and all these things, and I don't know. It feels like we're doing a lot of stuff, but maybe it's not so bad, because like this really isn't that big. It's got this sort of dispatcher function, and it's got the formatter that basically knows how to break up all the units, which that has to be done, or it just formats it simply. So I think it feels like a lot of pieces, but we're there. The last thing I want to look at, I think I should be breaking these out, at least rounded fraction. Maybe I can leave, well, I don't know. Let's see. We want this one. Domain. This might be a domain object, actually, huh? Okay. Let's pull out skosh. Oh, well, ValueFormatter's domain. This definitely is. Okay. We're much better splitting off the mechanical number stuff from the string stuff. I'm definitely happy we did that. Okay. And this fraction formatter, I guess that's standalone enough. I could see some other formatter needing to break out and use that independently. All right, number formatter, not in scope. skosh parts in the format can use skosh. Okay. Let's see. In the formatter. Oh, that shouldn't be there anymore. Oh, no, that's okay. Skosh cut off. Why is this? No, it's not. Skosh parts in the formatter. Well, these are the string parts, so I think they're okay. And that's really the string. I mean, all three of these should be string types, right? Yeah. Okay. So I think I got it with that, pulling that out. Okay. Well, we caught one anyway. All right. I think we're done. Oh, I haven't done my to-do at all today. FractionFormatter.format. Includes computation of split doubles. Yes. All right. Well, next up is EGT. Oh, we did this. We made a decision. Well, that was last time, really. I'll put it here anyway. Yeah. We'll pick up with the EGTest. So let's take a break. Yeah. Back in 3 or 4 minutes. Welcome back. All right. So EGTest is our parameterized testing package, and we import the current version, but we made some extensions for it. So one case was if your assert function can throw, we want to use try catch on it basically, and well, try and don't catch, just let it escape. All right. And the other thing we added was an assert equal that takes the actual value and the EG row, and then calls the expect, the message, the file, the line for you. Okay. If I don't do that, then you have to have your assert has all these things in it to catch up. Okay. This is definitely an improvement. All right, let's find a usage of this for an example. And we actually introduced this partway through, so there are places that don't use it that could. Okay, so yeah. I don't know if I can find one. Let's look for dot expected. Text in the project. Well, dot file. Right. Okay. Oh, that's an assert throws error. That's a candidate. Oh, I think I mentioned that possibility. Assert throws. Yeah. Okay. Well, assert throws error. it runs the try clause, and if it throws an error as string. Okay, well, that's sort of an assumption. There's probably errors. Don't they have a something description? We'll check that. Okay. Here's one. Assert equal. Yeah, so this one could use EGAssert equal like this one did, I think. Calc.error message. Oh, it's not quite, is it? Because this one, $0.input gets calculated here. Display of $0.input. I guess it is calc.error message. Okay, I think we can do that. We should be able to say EGAssert equals. The actual is calc.error message. The expected is $0. Okay, and nothing in this should make that a problem. 205. Okay, we can have both those, and then I'll delete them if neither one breaks when the other doesn't, or vice versa. Okay, so that seems to replace that. Where's our find? Assert equals. Now, that's a little different. Unfortunately, the expect. Because we can't have an equals method on a triple, which is too bad. So I don't think you get to escape it. Now this one's got a function of all these things rather than the expected value, so he can't do that. Yeah, okay. All right, so I guess I caught most of them. We did add one. Okay, so EGAssert equals. Well, I guess the thing I want to do. All right, I have the other project open somewhere. Let me fix that. Okay. Well, I have EGTest. What else? There it is. No. Oh, when I closed Xcode, it reshuffled. Okay, let's put this on the other side of that. All right. To do. Huh. Keeps taking me elsewhere. Oh. Where's my to do? Okay. And source. There's EG. In next case. Okay, I'm just using MIT. No reason to update that. Okay. EG. Okay, we have our check. And then in this project, okay, we do extension EGTest case, and we're adding this one. So I want to pull, oh, that's not in the extension. Okay. That's a top level function. And I think I'll put it here. And my style is now to not have these kind of comments up top. All right. Now, I don't know if there's a better place for it. How come I don't have to, oh, I do import EGTest already. Okay. All right, well, nothing should hurt it by being there. All right, and that is almost like an EGTest case extension. It's not really though, is it? Okay. What we don't do is we don't have any tests for this. So let's add some. Well, this one is assert using EGAssert. Okay. And actual is that. Oh, well, this should really be. I really tend to do this, which is what I want to encourage because I'm using it this way. Yeah. Okay, this test should pass. We'll break something just to make sure it's. Xcode up to its old tricks. Okay, I think that ran now. Expected failure. That doesn't seem right. Oh, maybe it's. Here we go. All right. So let's break it. I think I could say assert not equal. Okay, it's a little... This is where, like, the macro stuff maybe, right? I can rewrite it in place and it may not realize that it's an assert equal. But that's okay. I don't think I need anything there. Okay. So, all right. So we've added, well, I guess we updated files to house style, added EGAssert equal. Okay, and then we've got to document that thing. Okay, double struct. I guess this is a top level function. EGAssert equal. How do these other functions? They don't have arguments. Oh, they do. Say something, and then the triple quote thing is an example. I guess I should take my... if I can. I think I have a markup thing kicking around. Oops. That's not it. There we go. Okay. Now, yeah, I messed that up, didn't I? Seeing as I have it in my tests. Should be actual, an example. I'm going to switch these two as well. Okay. Thanks. Okay. All right. So now let's pull in the other one. Now, I did have a question on it, right? Okay, we did this. Update EGTest. Take a new check with try from content view tests. I think we kind of refactored around that maybe. Yeah. Okay, I think it's talking about this one. For test and throw, can we continue after ASC through? That's a good question. Update EGTest to take a check with try. Okay, from. All right. So, yeah, I guess with this one, for a test that can throw, yeah, so if something actually throws, we just throw it. Okay, and so the consequence is if two tests throw, the second one won't run if the first one fails. That's pretty typical JUnit style, or kind of most X units, but not XC unit. I don't know. It's kind of hard to know what's useful. I guess I should, if I do this. Okay, what would it take to do it the other way? I guess I would have to catch these. I guess in line 12, I would have to catch that and keep a something counter. There's no real try resume kind of thing. I mean, if I caught the exception, let's see where we use this. I think we saw it, right? It was that, was it this? Well, this one lets us deal with things that might throw exceptions. And if they fail, okay, I think we'll just leave it that it fails on the first one. Well, this is looking kind of tricky, isn't it? EGAssert equals try value. Parse input, we expect this. These ones are actual errors, so they're definitely more complicated. Assert throws error. Is that one? Yes. Assert throws error. Try this. Well, that sort of looks for an EGAssert throws error, doesn't it? With the problem that the error. Wait, what's. Yeah, that's what I'm not quite sure of. I mean, I'm getting it here. Assert throws error. Let's see. I want to get an error here, right? Assert throws error. So I try the parse. I expected this. That's a little funny for me, but okay. Expected. I guess that's. He's not really using. Oh, he is using expected. This is the error. Let me look at this thing. I haven't used this one enough to be confident, I guess. Okay, so Assert throws error. Expect failure. Okay, let's look more broadly. Okay, we evaluate an expression that can throw. We provide a message. We catch the file in that. An optional error handler. And then what are we doing? Okay, so the value, there's no real expected value per se. These are more like a message. Okay, so they try that and then they get an error and then they check that the error is what they expected. But I guess the test passes, right? If, well, let's try this. Let's make an error in there. And we expect line 43 to have a problem. It's going to fail on this line, right? This part's okay. Okay. Right. And then what's the problem here? Closure number 1. Okay, but if I take that off, I think it's got a default handler, right? Yeah, so nothing extra would call. So if I were to take these out, then the error handler's defaulted. Okay, and I expect all these tests will pass because they throw. But now it wouldn't detect this. Right. Okay, let's undo this. Make sure that's back to normal. Yeah, if it doesn't throw, that'd be a good one. So 1 to 25 is valid. So it should not throw, but it's going to throw and complain. Yeah. Did not throw an error. Expected too many. Expected too many is the message, even though it's coming from the expected value. Okay. Well, all of this, okay, the exception throws the error. I mean, like this throws an error. So the whole thing throws an error. I don't know if assert throws itself. Does that throw an error? It does not. Okay, otherwise it would have throws here at the end. Okay, so it only throws an error because we threw one. Well, it seems like the only thing is the other thing is I was looking at error, right? And what is his type? Is error? I think error has, like, your errors don't have to be strings, right? Yeah, like here's an example. Okay, but they have something, right? They have this localized descriptor, localized description. And I don't know if that defaults to anything. Okay, so this is Swift error. This way. Okay. Yeah. Implemented protocol extension, so there's nothing to override. Type weight interface for enums. But you can get around it. Most use the no localized error protocol. I don't know about that one. Okay, sorry, let me make sure that's still green while I'm thinking this through. Okay, so what I'm rebelling against is error as string. And what I don't know is if it worked with error actual equals error dot localized description, if it defaults that to a string value when it is a string. Okay, let's check. I mean, it would be reasonable for it to treat the string as the name. Reasonable and not happening. Okay. And then what did somebody mention was localized error? Error message describing what error occurred and the reason and the suggestion. Well, that's all great stuff. It doesn't leave me knowing what to do. iOS 16, so it is relatively new. Well, I don't know. I don't think I've ever seen anything using it. All right, so this error can't be completed. Swift string error 1. That's not a great path. Okay, well, I think I just don't know if... So I guess what I'm looking at is, should I create an EGAssert errors that marks the file line automatically, but jeepers, that's not... I don't think I can make assumptions about this coming from the expected, and I certainly can't make assumptions about how do you know you've got the right error. All right, let's make sure we're back to green. All right, so I don't think I'm going to deal with this one. Error string. Oh. I do want to allow for this try check thing. Now the question would be, I mean, kind of back to your question, can you catch the thing? All right, so let's go back to our actual thing here. So I would have to capture the error. I don't even know if it would type check, but I would capture the error. I don't have line and file on the error, so I'd have to, I'd still know it was in there. I mean, there might be a way. Yeah, we can make a closure optional. Assert function. I mean, the if we did the other test assert throws thing, they defaulted that assert function. I mean, you're not required to make any assertions about the error itself. It just detects that you threw one, and if you don't throw it, it complains, and if you do throw, it passes it on to that, and you can make further assertions on the actual error. This lets you do that. Okay, so this again, let's find usages. Oops. So I think we just went to the first one. Right. So even this case where you're not throwing exceptions, this is still, this check is useful because values strategy.parse can throw an exception. So even though in this case they're all legal numbers, so we're not expecting an exception, because it's a exception throwing method, we have try there, and we have to have a try on the check too if we want to let the error just escape and not handle it. I'm pretty good. I'm okay with that aspect of it. Sorry, it was 26. Formatting bugged me. Now this one was more complicated because it uses assert throws error, and it checks this. I mean, if I did EG, you still wouldn't. Well, I mean, I wouldn't want to give you, really, I would want the message to come from the message, and that doesn't make any sense here. Okay, so if you don't throw an error, you get that message. I mean, if it's that expected error not thrown, that's not terrible. All right, let's make it up and see if we like it. EGAssert throws error, and we would give it this and EG, well, $0, and I guess we would have to give it this. which means we would still have to, well, this can be $0. No, it can't. We had to capture that $0. Otherwise, we're trying to get the $0 from here, which is not right. So let's let example equal $0. And then we could do EGAssert equal actual example, because that's the expected. It really wouldn't be quite right. Would I expect? No, that would be okay, I think. All right, let's make this baby up and see what happens. How are we doing in time? Okay. I guess this is another top level function. And we got a, well, he's not really a T, is he? What is he? Where was I? Value parse dirty tests. He's really a throwable expression. He said parse returns a value, but he throws. Yeah, I don't know if I can make this quite do what I want. I don't think the burden is so high. Well, let's see the type of this thing. Expression. Yeah, that's probably a place to use auto closure if I understand it. So it's turning that into, well, no, I can just say expression. I think auto closure defers evaluation until it needs to, but we don't really, I mean, we always need to evaluate that one. Okay, so that expression, I'll leave off auto closure for now. Nothing throws T. Okay, so that's our call to some type, but then my expected, I don't expect that to be anything. Let's call this T1. Because we're expecting an error, so we don't really care. We don't expect it to return anything. All right, and then we are going to, I guess I'll call this example of EG of input and T. And we need this function. Error handler goes to error, goes to void. That stuff is similar. Error handler takes an error, returns a void, and we give you a default method. That, okay. And then this is comments. error. Input T. All right, and I'm sorry, I gotta look at EG again. EG T is the output type, the expected type. I guess this is T1 does not need to be equatable. Expected of equatable. Yeah, closure's optional with this. Okay. This is almost like ignored. Okay. Now this is going to look a lot like this. And just seeing if it makes sense, I don't know. I guess we'll test it after. It's tricky. Okay, well, this is certainly expression. Do I have to call parens on that? He only gives you the error. Error in, and then I think we have to call our function, right? Error handler. Of error and how do we get the line out? I mean, I'm going to pass the EG to this case. I don't know. I think my function is more like error handler is, it's a function that takes EG of ignored expected. These names are killing me. I'm just going to make it EXP. And X. Oh no, this is input. Well, maybe, I don't know, maybe people don't. I'll do all caps. They look really powerful. Expected of equatable input. Okay, expression. Nothing throws ignored. And this really is input. Expected. Now the error handler, I think you have to give me a function that takes an EG. Right, somehow I have to pass that example into you. Okay, so if you gave me an EG of expected and error, I expect I will create a function. I don't know. Let's see. I'm going to give you an EG. EG input expected. Okay. Produces an error. I think it produces a function from error to void. And this is wrong, but we'll take care of that momentarily. Okay, I don't know. All right, so you give me a function, like this is putting a lot on you as a callee. You're going to give me a function that if I give you an example, it'll take an error. Okay, and so here, this mess, and I need to call it with a function that goes from error to void. Okay, so I got to do error handler of example. Well, I think this is error handler. Oh, it's anonymous. Okay. I don't know. This is very meta. Extra label. Okay, yeah, that's an unlabeled thing. And a separator. Okay, so this, well, my type's okay. So you pass, and you're going to be given an example. All right, and then what do you call this with? Okay, and so, all right, Well, supposing we had this right, what would we call it with? Let's see if we can, yeah. All right, we're going to do EGAssert error. All right, it gives us this expression. It evaluates it, and I may need an auto closure. I don't know. We don't pass this argument. We don't pass this argument. We just pass. Oh, shoot. That's the good one. Okay, try value parse input $0. And then the third argument is the error handler. Ignored could not be inferred. Cannot turn value of type to expected type. No, wait a minute. And I guess let's get this third argument right. The error handler is, I think, well, okay, we can call it there, I think, but it's given an example in, and then it's going to return this mucky mess, I think. Well, let's see how it likes to format that. Cannot convert value to type. Nothing throws to ignored. Okay, let's put the auto closure in. Maybe that's a place where we need it because I don't know. Auto closure. Okay, I'm just gonna. Which time are we looking at? Not very much. It's to improve performance. Oh, I like plots and stuff. Let's go there. Auto closure applies. Automatically creates a closure from the expression you pass in. It isn't a closure, but it becomes a closure. Okay, so it lets us avoid the braces. Okay. Doesn't need braces. Result, print double. Okay. Well, whoa, everybody's happy now. I don't believe that. Okay, we'll see if it works. Okay, closure parameter position. Closure parameter should be on the same line. Oh, very boring. Oh. Okay, and then I think the style people use is more like this to trigger you to think something else is going on. Okay, so let's start breaking it and see if both these complain at the same time. Okay, that's not heavy. All right, but we did not catch it. right? And he's all hung up on that, but closure. So it's not working. All right. Let's take this one out. Oh, both these are identical. Okay, only one of these complains, so they are not equivalent. And this is where I wonder if this is messing it up, the function. Let's make sure we're called at all. All right, let me comment about. Let's break the first one instead of the last one. Okay, so example is /xx can't start message empty file line 32. Okay. And then the actual, well, isn't anything yet. Okay, let's step over. Actual is can't start with backslash, I think. Okay. And then example.expect. Why would this not fail? Okay. Well, I don't know. We're in the ballpark. I feel like this, I mean, we've got, I don't think these are helpful at this point. We've got the type as I expect it to be, or at least modulo this default. But, I mean, the type is a little weird to write. We run your expression. This is not customizable, so that's kind of annoying. And then we call error handler. We're clearly calling it. An error handler of example is a function on example. So we should get back this function, which is a function on error, which should go. Well, let's put this in there, and then I'll call it a day. All right, so I'm going to run the same test again. I think my throw is disappearing. Oh. Okay. Well, it's something involved in that. I think it's worth a little bit more time on kind of spiking the way through this, or I don't know what you want to call it, but I am not throwing something the same way because this assert equal catches it and the EG does not. So I think we're close enough to something that it might turn out to be useful. I don't know. You're saving these two lines of code, really. Well, and this one, I guess. You're losing the flexibility on the first of those, and you're saving yourself typing the two. Even when we get it together, I'm not sure it's worth it, but we'll deal with that tomorrow. So tomorrow, Tuesday, 2 to 4:30 Eastern, 6 to 8:30 p.m. UTC. And thanks for joining today. I hope I catch you in the future. Take care. Bye-bye.